Miss Osmond, what are you doing with that empty Coke bottle?
Well, you know, Mrs. B, I just finished drinking this Diet Coke, and it just happened to be turned to the ingredients, and I was reading about them, and there's a fair number of acids.
Acids?
Yeah.
What kind of acids?
Phosphoric acid,
Whoa.
citric acid, and then of course, you know, the CO2 dissolved in the water that they, you know, makes it fizz is carbonic acid.
That's kind of scary. We're drinking all those acids?
We're drinking all those acids, and I think sometimes that's why my stomach gets upset if I drink too much soda.
Ah, we've got acid in our stomach. We add more acid to it. Yeah, that makes sense. Oh.
Yeah. So,
well, now that we're talking about acids, why don't we talk a little bit more about what we could find out about them?
okay. Acids are kind of funny because they're really molecular substances. They're covalently bonded. But when you put them into water, they actually separate into...
So we've got covalent things that become ions?
So when you have like hydrochloric acid, which is a hydrogen and a chloride ion, you put it into water, it separates into hydrogen ions and chloride ions.
Okay, because the hydrogen becomes positive, where the chlorine is negative.
And so they have their molecular compounds that have something that we call an ionic tendency.
Interesting.
So we talk about acids in our covalent unit because they are a molecular compound.
Okay.
Okay. And the drawback to acids is they're very hard to name. The naming rules are very...
I don't like hard stuff.
I know, but we've got tricks. We've
Okay.
got tricks to help.
Tricks are always
Tricks
good.
are good.
Yeah.
Okay, so let's look at how we are going to try and name these acids.
Okay.
First of all, there's two types of acids. We've got binary acids
Binary, again, two.
and polyatomic acids.
Okay, just like we had the polyatomic and binary ionic compounds.
Exactly.
Good.
Okay, so a binary acid is going to be some acid that it has only two elements.
Okay.
Not two atoms, two elements.
Two elements, right.
So that would be something like HCl, hydrogen and chlorine.
Okay.
For example, you have hydrogen and chlorine together, and they make hydrochloric acid.
Hydrochloric acid. Hydro, hydrogen, chloric, not hydrochloride? You don't call this
No, in acids we change the ending to ic instead of ide.
Oh, because like this isn't a metal, like in the ionic bond.
Right,
Okay.
right.
So hydro for hydrogen.
Right.
Okay. And then chlor, and then we change the ending to IC
C.
instead of IDE, hydrochloric.
Right.
Okay, so if we had this one, HBr,
Hydrobromic.
acid, that makes sense. Oh, I have to put acid at the end too, right?
Yes, you do have to put acid.
Okay, so we know because it starts with an H and ends up something else that it's going to be an acid?
Yes, but you have to be careful because right now we're going to say that everything starts with an H is an acid. But there's another type of acid that we have that's made from polyatomics
Okay.
with hydrogen.
But with the binary ones, if we have a hydrogen and then it's followed by a
non-metal.
So H and F together.
Right. That would
Hydrofluoric acid.
Yes.
Do you know the trick for how to spell fluorine that Miss Riley told us?
No.
Fluorine has the flu. FLU.
I like that.
Hydrofluoric, because everybody wants to put an FLO
Oh,
without the U.
yes.
Hydrofluoric acid.
Okay.
So the binary ones don't seem too hard.
No, binary ones are very, very straightforward. What messes students up a lot of times is they look at, when they see an H, they say hydro. They say hydro something, okay? And it's only hydro when it's two elements.
Okay, so as soon as we get into the polyatomics, it's not hydro anymore.
It's not hydro anymore.
Right.
And that's how you differentiate between a binary acid and a polyatomic acid.
Okay, so now if we have a polyatomic acid, you don't use hydro.
Right. You look at the ending of the polyatomic.
Okay.
Okay, so if we had a formula that ended with the SO4, the sulfate ion, we would change the end. We would say instead of sulfate, we would say sulfuric. We would call it sulfuric acid.
Sulfuric. So, for instance, well, we'll check these in just a minute over here to
Right.
see what these are going to be. And then if it ends in ITE,
So sulfite, if there was a hydrogen with the sulfite ion, we would call it sulfurous acid.
sulfurous.
Okay.
Sulfurous and sulfuric. Okay.
Now, the trick to remembering this is to say the phrase ate ic itis. So, ATE dash IC, okay, ATIC, and then ITEOUS. ATIC-itis. It sounds like a disease.
It does, ATIC-itis.
Yeah, ATIC-itis.
Okay.
And that's how my students remember how to change the ending.
It goes to it, I goes to us. I love it. ATIC-itis. Okay.
So
here's some examples up here, right?
Okay. So our first acid there is HCl. All acids start with hydrogen, no matter what. So there's one element.
All right.
Our second element is Cl in this one, so it's two elements, so it's binary.
So
we're going
from
to
the
call
last
it
slide, hydrochloric acid.
hydrochloric. Very good. Okay. Now, if we look at the next one, we have a hydrogen, a nitrogen, and an oxygen. I'm not counting atoms, I'm counting elements. So I have 3 elements.
Okay.
So that is no longer a binary acid, it's going to be a polyatomic acid.
It is. And I don't remember NO3, actually I do, but the students may not. So I'm going to get my handy dandy cheat sheet out here and find out that NO3 is nitrate, right?
Nitrate would go to
ic. Okay.
So then we call this nitric acid.
Nitric acid, okay.
Oh.
Now our next one here, SO4. Again, I'm going to look on here, and SO4 is sulfate, and 8 goes to ic.
Right.
So we're not going to say sulfic, it's sulfuric.
Sulfate and phosphate. We don't just change the endings to ic or os.
Okay.
We add an R in there. So phosphate becomes phosphoric.
Okay.
Sulfate becomes sulfuric.
Okay. I like that better. Sulfic, it just
It sounds funny, doesn't it?
Sulfuric.
Yeah.
And I've heard of sulfuric acid.
Yes. So
and that's what this next one is.
That's H2SO4.
Sulfuric acid. Okay.
Right. All right.
Now our next one here, CO3. So if I look on my little cheat sheet again, I find CO3 is called carbonate. 8 turns to ic. So carbonic. It's not carbonic. We call it carbonic.
Carbonic.
And that's what you said. Yeah.
Yeah, that's one of
carbonic
those
in Coke.
presents.
So we've got some carbonic acid in Coca-Cola. Wow.
Okay.
Interesting.
Yeah.
Now our next one here. Ooh, that's long.
Next one's a good challenge.
We
got to find that. It's right at the top of the -1.
It is acetate.
Acetate.
8 turns into ic. So acetic.
Acetic acid.
Acetic acid. I've heard of that before. Isn't that also known as vinegar?
That is known as vinegar.
All right.
All right.
Now our next one, H3PO4. PO4 is phosphate.
So we're going to 8 to ic.
And you said phosphoric. So phosphoric acid.
Right.
No, that's not that hard.
And if you had, say, H3PO3, PO3 being the phosphite ion, it would become phosphorus acid.
Okay, so far we've done all the ics.
Yeah, so let's do some os. Yeah, so let's do some os. Okay. So how about HNO2?
HNO2. And we don't call it hydro because it's a polyatomic.
Right.
NO2, we're going to look up on our sheet. We're going to see that NO2 is right here, and it's nitrite. So we're going to call this nitrous acid.
That's it.
This is it. Nitrous acid.
I think what happens is the students see the H and they think hydro immediately for everything. And what they need to do is stop and count the elements.
Okay.
So in this case we have 3 elements, so it's no longer binary. So hydro's out the window, and we're going to name it after its polyatomic.
So as soon as we see one that we know is on this chart here, it's no longer hydro.
Exactly.
No hydro. Okay.
I like to tell my students if you count the elements and there's 2, I want your neck to go up and look at the wall for the periodic table. And if there's more than 2, I want your neck to go down and be looking at your polyatomic sheet.
I like that. Good ideas.
Okay, so let's do some more examples.
Okay, hydroselenic. Wow, selenic. That's because SE, selenium,
right,
changes into selenic. Okay.
Right, we add the IC on the end.
All right, HCl, we've done this before, but tell you what, students, what I want you to do is to pause, get out your periodic tables, get out your polyatomic ion sheets, write down each one of these on your notes, and write down either the name and the formula, or I want you to have everything written down. So you should have 1, 2, 3, 4, 5, 6, 7, 8 different things written down on your sheet. Pause while you do it. Then when you're done, you're going to show the teacher what the answer is.
All right. Okay.
Welcome back. Do we want to actually tell them the answers?
Yeah, let's tell them the answers. That way they can
check your work.
check the work.
And tell you what, after you check your work, put a check mark next to it if it's right. If it's not right, don't erase it. Don't put a check mark. Just draw one line through it and then write the correct answer. That way we know that you're following directions.
Excellent. Okay.
We already know the first one. Second one.
I count 2 elements, so you are naming it correctly.
Okay.
We're going to take chlorine and change the ending to ic, and so hydrochloric acid.
All right.
Okay. Now the next one, let's count elements. 1, 2, 3.
Right.
So no hydro.
No hydro. Our sheet here.
Sheet.
NO3. Let's see here. Nitrate. So it's turning to an ic.
Right.
Nitric acid.
Excellent.
This isn't so bad.
Okay. And next one, 1, 2, 3 elements again.
Get
There's
this
the
guy.
sheet.
Sulfate. It's going to be sulfuric acid.
Right.
Okay. Nitric.
So when you see the name,
Nitric ic. It's going to have to come from
8-ic.
here.
So you think 8-ic.
Okay.
So nitric would come from nitrate. So the formula is going to be,
Well, it ends in NO3,
so we know there's going to be a nitrate.
and NO3 has a charge of -1.
Right.
And so it's going to have 1 hydrogen to make it.
So yes, when you put these formulas together, you need to cross and drop your numbers, or one of each if it's electrically neutral to start with,
Okay.
which HNO3 is.
Excellent. Now,
Okay. Phosphoric,
same kind of idea.
right, comes from the 8 ion, so
Okay, so I'm going to look on here. I'm going to find phosphate.
phosphate.
And when I look, I found that phosphate. You know what's neat? When you start using this a lot, eventually you get it memorized to where you don't have to keep pulling this out every time.
Yep.
But since we're just starting to learn,
That you're going to use it
we're
a
gonna
lot.
find this.
I told
So-
my students it's going to be very dog-eared by the end of the semester.
it is. So phosphate is PO4,
Right,
and it has a charge of 3-.
right,
So we're going to have 3 hydrogens in order to balance out this.
correct.
H3PO4 is
Right.
going to be phosphoric acid.
Okay, how about oxalic acid?
Well, that sounds like a big giant cow to me.
Well, we got an ic ending, so we're going to go for an 8 ion.
Oh, I see oxalate. I hadn't heard of that before.
Yes,
Okay, oxalate.
oxalate.
Okay. And oxalate is C2O4, and it has a charge of -2. So we're going to have 18 hydrogens to go with the 2.
We're going to just need 2 hydrogens.
Okay, that sounds better.
Plus 1, each hydrogen plus 1, so 2 of them would make +2, and it would offset the oxalate of -2.
Sounds good.
Okay. Now we've got another name.
Hydro. As soon as I hear hydro, I know H goes first.
Yeah, as soon as you hear hydro, up pop your head, look at the periodic table, and iodic would come from iodine, and they're both, one's +1, one's -1, so
I like that
HI.
one.
Hi!
There we go.
Okay.
Very good.
So, and we'll have sheets for them to practice
Okay.
the acid naming on.
These aren't so bad.
Yeah.